So what's up guys, we are back again for another video, but this time it is a tutorial video. In this video, we are going to learn how to solve a molality, freezing point depression, first law of thermodynamics, which is the calculation of work, heat, and internal energy. So let's do it. So what is molality? Molality is the property of a solution and is defined as the number of moles of solute per kilogram of solvent. The SI unit for molality is mole per kilogram. The formula is M is equal to mole all over kilogram, which is the M is equal to molality. Mole is equal to moles of solute. Kilogram is equal to kilogram of solvent. So here's an example. Calculate the molality when 75 grams of magnesium chloride is dissolved in 500 grams of water. So the given is mass of solute is equal to 75 grams and the mass of solvent is equal to 500 grams. So in order to find the molality, we need to find first the moles using the molar mass formula. So the formula is mole is equal to mass divided by molar mass. So it is equal to 75 grams divided by, in order to get the molar mass, we need to add the two atomic weights of the two constituent atoms, which is the magnesium and chloride. So the atomic weight of magnesium is 24.31 grams plus the atomic weight of chloride is 35.45 grams times 2 because it has two atoms, and it is equal to 75 grams divided by 95.21 grams per mole. So it is equal to 0.78 mole. So now we have our mole. So the problem is our mass of solvent is grams. So we need to convert it into kilograms. 500 grams times 1 kilogram all over 1000 grams is equal to 0.5 kilogram. So now we can get the molality using the formula. So M is equal to mole of solute divided by mass of solvent is equal to 0.78 mole all over 0.5 kilogram. It is equal to 1.56 m. So that's how you calculate the molality. So what is freezing point depression? So freezing point depression is the decrease of the freezing point of a solvent on the addition of a non-volatile solute. The formula for the freezing point depression is delta T of F is equal to IK Fm. So the delta T of F is equal to freezing point depression, K of M is equal to cryoscopic constants, M is for molality, and I is for Van Hoof factor. So I is the number of particles of a solute. It is always equals to 1 unless it is an ionic bond. So here's an example. Given that the K of F of water is 1.86 kg per mole, what is the freezing point of water if 14.9 grams of potassium chloride was dissolved in 500 grams of water? So the given is mass of solute is equal to 14.9 grams, mass of solvent is equal to 500 grams, the K of F which is equal to 1.86 kg per mole, and the I which is equal to 2 since the potassium chloride is positive and negative charge. So the first thing we need to do is find the molality. So in order to find the molality, we need to find the moles using molar mass formula. So M is equal to mass all over molar mass is equal to 14.9 grams. In order to find the molar mass, we need to add the two atomic weight of the two atoms, which is the potassium and chloride. So the atomic weight of potassium is 13 39.098 grams per mole plus 35.45 grams per mole, which is equal to 14.9 grams all over 74.55 grams per mole, which is equal to 0.19986 mole. So the problem is our mass of solvent is gram, so we need to convert it first into kilogram. So 500 grams times 1 kilogram all over 1000 grams is equal to 0.5 kilogram. So now we can get our molality. So M is equal to mole of solute all over mass of solvent. So it is equal to 0.19986 mole all over 0.5 kilogram, which is equal to 0.3997 m. So now we're going to get our freezing point using the formula of changing of temperature is equal to IKFM, which is equal to 2 times 1.86 degrees Celsius kilogram per mole times 0.3997, which is equal to 1.49 degrees Celsius. So that's how you get a freezing point depression. First law of thermodynamics is a version of the law of conservation of energy adapted for thermodynamic processes, distinguishing two kinds of transfer of energy as heat and as thermodynamic work, and relating them to a function of a body's state called internal energy. The first law of thermodynamics is given as delta U is equal to Q minus W, where delta U is the change in internal energy of a system, Q is the net heat transfer, and W is the net work done. The sign convention is Q is positive if the heat added to the system, W is positive if work is done by the system, Q is negative if heat leaves the system, W is negative if work is done on the system. So, here's an example. 2000 joule of heat is added to a system, and 2500 joule of work is done on the system. What is the change in internal energy of the system? So the first thing we're going to do is write down the given formula, which is the heat is equal to positive 2000 joule since the heat is added to a system, and the work, which is negative 2500 joule because the work is done on the system. So we simply use the formula, which is the delta U is equal to Q minus W, and we simply substitute the value. So it is delta U is equal to 2000 minus negative 2500 is equal to 2000 plus 2500 is equal to 4500 joule. So that's how you get an internal energy of the system. So that's all for this tutorial video. Thank you for watching.